Hey everyone, welcome to PrepTrain. There is often a huge gap between the incredible tools we use every day as engineers and the academic research papers where these ideas were born. We are often taught how to use a tool, but rarely why it was built the way it was. Today, I'm very happy to kick off a brand new series on this channel. I'm calling it Break the Tech with Saheb Kumar. And over the next few months or next few years, I don't know, we are going to deep dive into the most influential and groundbreaking tech research papers from the last 2 decades. We will be going in detail for the deep dive and decode the documents together that literally invented the technology powering our modern world. The benefit for you, you will gain a foundational understanding that goes way beyond the typical tutorial. You will learn the core principles behind tools like distributed systems, databases, and machine learning frameworks, which will make you a better problem solver and a more effective engineer. So, to kick things off, we are starting with an absolute giant in the world of data engineering. Our first paper is this one right here, Apache Spark, a big data processing engine. I went through this research paper in the last 1 week, and it was a really awesome thing to read. If you have worked with large amounts of data, you have heard of Spark. It is the engine that took the idea of MapReduce and supercharged them with in-memory computation, and it revolutionized the entire tech industry in terms of data processing. I'm choosing this paper because it's a perfect example of brilliant academic work that led directly to a tool used by nearly every major tech company on this earth. In today's video, we are going to break it down section by section, the entire research paper. Now, it will be awesome if you will follow along and have all the resources that you need. So, I have put a link in the description below for all the supporters of the channel and my work for the PPT that I will be using in this video, along with all the detailed notes for this video that I have created. And as a special bonus for all my channel supporters, they will get the access to this scanned PDF of this my personal copy, where I have used and highlighted everything important based on my understanding, and I've also added few notes and questions in the margin. You can, of course, find the original research paper online by doing a simple Google search. So that's enough for an intro. Let's start the first ever video of Break the Tech series, and let's get in the world of Apache Spark. Welcome to the first video on Break the Tech with Saheb Kumar. Today we will be discussing this Apache Spark, a big data processing engine paper. PPT is right here. Uh, why I choose this paper is something because I think Apache Spark, the introduction of it when it came, it changed how the world used to view uh, big data and its processing and its analytics. So before big data, there was something called as Hadoop MapReduce, which was suitable for that point of time. But eventually, companies realized that it's not possible for them to wait overnight to just get the result of a query. Or Hadoop MapReduce was used to run a batch job. Basically, I will discuss everything in detail again. But there came a time when people realized that we need a more faster way, and we will also talk about how much fast Apache Spark is with respect to uh, Hadoop MapReduce. Apache Spark introduced the concept of in-memory computing at scale. So this means that the results were around 100 times faster than Hadoop MapReduce. And not as a platform, Apache Spark was giving like batch processing, stream processing, then machine learning libraries, and various kind of graph analytics and various kinds of tools bundled together. And as an organization, companies really loved it when they saw that, okay, by just incorporating one platform, one tool in their workflow, they can actually unify all of these different kind of things all at one place. And this used to save their time and workforce, by instead of integrating different tools and platforms at separately, they can do all things at one place. Before starting the actual video, I would like to tell you and share with you few keywords that I found in this research paper while going through it. And I think that whenever you get time after this video or whenever you want, you can just go through these concepts again. Like they have been mentioned in the research paper many times. And I will discuss them briefly, but it will be good for you if you go and deep dive further into these topics. So there is batch processing, there is stream processing. Both are kind of processing that are being done by big data analytics engine. Apart from that, there is this concept of RDD, or resilient distributed dataset, that we will see again in upcoming slides. These are basically uh, immutable datasets. There is MapReduce that I was talking about just now. So the MapReduce is basically the previous version of Spark. There are transformations being done on the mini batches that we will see again. This is part of both MapReduce as well. There was transformations being done, and there is again on Spark as well. We will see cluster manager mentioned in the paper, and there is a fog computing that you can look up to. So the question comes, why do we need a powerful analytics engine like Apache Spark? And the answer lies in the term big data. Big data as a term has been there for years now, but its implications are important today more than ever. Big data basically means data which are so huge, coming at so much speed that it cannot be processed by a traditional database systems. When we talk about big data, there are three V's that we use to define it. These are volume, velocity, and variety. By volume, we means that the volume of the big data is big enough. By velocity, we means the data is being generated at a very high pace. Think of a social media platform like Instagram. It is tracking every link that is getting clicked, every post that is being liked, every hashtag that is being used, and whatnot. Everything is getting tracked, and these are being dumped somewhere. So these are big data. The final V, variety, refers to the complexity of the data that is coming up. It can be unstructured text, it can be JSON, it can be image, it can be a video, it can be logs of millions of lines. This is where the traditional database fail, because they were designed to handle structured data in a centralized manner. In this vast ocean of big data that is coming up, they will not be able to find patterns, recognize trends, and everything in the data itself. And that is why we need a proper system which can grow along with the data. So the big data will keep growing further and further. This is the problem statement that led to the rise of initial systems like MapReduce and later on to Apache Spark. In order to understand and appreciate what Apache Spark is doing, we need to go back and understand what its predecessors were doing. So, here is a classic example of the hello world of MapReduce, which was prior to working for, I think, a decade, after which Apache Spark came. So let me explain you the example. So in here, let's say we have a file containing a million or trillion records, and each are having these words only mentioned of these words. Let's say deer, beer, river, car, and all. Now, first of all, when this input will come, what will happen? That in the input phase, the massive data set will be broken down into smaller pieces. So this whole data set that we have here, it will be broken down, let's say, into three words each, and these will be chunks. MapReduce framework will first break down this entire chunk into smaller pieces of, let's say, three words. So this become deer, beer, river. Then we have car, car, river, and then we have deer, car, and beer. Now each of these chunks will be processed in parallel. Next is the map phase. So in the map phase, what will happen, that there will be a machine in each cluster which will pick each of these chunks independently in parallel. Now its work will be very simple. Whenever they see a word, they just need to write it down and signify, as we are doing the word count problem. So they will just signify that it has identified this word, like find this word at least once, like one time. So this becomes deer one, beer one, and likewise river one. And then again, similarly, second machine will again do, like, okay, car I have identified one time, then I have identified another car, so it will make car one, likewise river one, and likewise with other thing. Eventually, all of these different machines will break it down, and then the next phase of or intermittent phase, we can say intermediate phase of shuffling will happen. In shuffling and sorting, what happens, the framework collects all these keywords that it collected, and it will then put them together. Now all the beer will be put together, all the car will be put together, all the deer will be put together, and all the river will put together. Now, but the thing is that, let's say if we are having 100 machines and each machine was processing in parallel. So we were having some 100 machines over here, and each machines were processing in parallel. Now if this machine is processing beer, then, and if this machine had a beer, so it will send it to this machine, likewise this machine will send it to this machine. So data transfer will take place. And likewise, for all the machines that will choose whatever, one machine can choose like, process multiple words as well. So eventually all of these words will be shuffled and sorted out at different machine, whoever will be assigned which machine by the manager. And eventually then the reduce process will start after the grouping has been done. And once the reduce phase begins, the reducer function is applied to each unique list. So let's say this beer one, and what it will do, it will just perform an aggregation on the entire list. So it will see that, okay, there are two beers, so it will mark it as beer 2. The second machine will again do the same for car. It will see that there are 3 cars, so it will do the aggregation, and likewise for all the objects. And eventually all of these machines will then again send back the data to the central server, or the manager basically, and then it will give back the result to the actual user who asked for this query. Now the user will get this data. So user will get this data. Now this is looking simple, looking easy, but where the problem is. Hadoop MapReduce was built for reliability. So what it used to do, that is used to write the intermittent data of the map phase, the reduce phase back to the disk. And then the next step, whatever it will be, it will fetch the data again from the disk, and then it will resume the process. This constant slow IO was the exact performance bottleneck for which the Apache Spark was designed to solve using the in-memory computation. Now that we understand big data and the problems with the earlier frameworks, let's discuss the different categories of big data frameworks. First of all, we can have a batch only framework, a stream only framework, or a hybrid framework. Now let's discuss in brief only like each type of this. Batch only frameworks are designed for high throughput. They can handle enormous data. But the problem with them is they are not designed for speed. They are not designed for speed. All right. They basically work by collecting data into large and fixed batches, and then they process each of these data all at once. So if you want to run a manual job overnight, they are good for that. Even the MapReduce that I was talking about is an example of a batch processing framework. On the opposite end of this spectrum lies the stream only frameworks. Here, the objective is to have minimum latency, and these systems are designed to process data in near real time, basically event by event. So let's say a credit card transaction is happening. So in order to analyze that whether or not this transaction is like following some kind of fraudulent activity that we have seen in past from the older transaction, So this kind of analysis cannot be done the next day because transaction is happening right now. We need to find whether this is a fraudulent transaction, and if yes, we need to block the transaction right now only. In order to do so, we can use stream only framework, and for example, Apache Storm and earlier version of Apache Flink were examples of stream only frameworks. But the problem with them were they had their own kind of languages for coding them, so that was a bit difficult. Now let's talk about the hybrid framework. So this is where Apache Spark is the hero. So a hybrid framework not only does the, well, it does both. It does the batch processing, it does the parallel processing, so it can do both. This is a massive advantage for us because Apache Spark offers a unified programming model. So what does this mean? We will again discuss this in detail later on. But the thing is, ki you can use the same model and the same core batch engine to run both the batch processing as well as stream processing as well. And for stream processing, there is a concept of micro batching that we will discuss. How S- Spark basically achieves parallel processing. So under the hood, it is batch processing only, but it's just the batch size is very small. Let's say of 1 second. So there will be a very little, like small bit of latency, but eventually it will be done in almost, like I said, near real time, not real time. So now the benefit of this is that from a company perspective, from an organization perspective, they don't need to maintain two separate tools or platforms, or to just do these type of analysis. Apache Spark is offering both. All right, now that I have given you enough background about big data and Spark, now let's get back to this paper, and we will start with the first section of it, which is abstract and the introduction, which is mostly page 1. I have mentioned it here in the slide as well. And the paper basically starts with the introduction of Apache Spark, and it says that Apache Spark is a powerful consolidated analytics engine for large scale data processing. Let's break down each of these one by one. So, what do we mean by powerful? Powerful means, again, powerful, and I think large scale data processing are related. So, large scale means big data, and powerful means it can do it very fast. Consolidated means unified. Unified as in, before Spark, a typical big data pipeline, let's say, it was a monster of various different kind of technologies. So you have to use one system for batch or ETL, and then another for interactive SQL queries, and then a different library for machine learning, and likewise. We talked about how MapReduce was writing every time the disk to data, and the next step will pick up again data from the disk. So Apache Spark, what it is doing, it is using the RAM of the system to store and process everything in between. Basically, it will use the disk only 2 times in the entire process. First, to fetch the data, and eventually at the end to store the result. That's all. Everything else will be done in memory until unless required, like there might be some requirement like resource are not there, but if resources are there, it will use the entire memory to handle the entire operation. Now let's look at its core capabilities. So Apache Spark supports both batch and stream processing, as it's a hybrid framework, and it also supports popular languages like Python, Scala, Java, and R to basically interact with its API. So even if there are different companies and each companies have different types of developers, internally they use different programming languages, the company can instead of investing in a new kind of language to interact with a new kind of system, the developers can directly interact with their own languages that they are using in their company, and talk with the API and do all of these consolidated things, like I said, machine learning, pattern recognition, big data analytics, all at single place. This combination of a unified engine and in-memory speed and a very friendly API is what made Apache Spark the de facto standard for the entire industry in terms of big data. All right, let's discuss about this Apache Spark section on page 2. Uh, we have here talking about Apache batch processing model and stream processing model. So we will discuss both of them one by one. So, like I said earlier, that one of the advantages of Apache batch processing model is its full in-memory computation. With contrast to MapReduce, that also I have already said, ki MapReduce used to read and write to directly to the disk at each intermittent steps, whereas Spark interact with only two times with the disk basically to load the initial data into the memory and eventually storing the final result back to the storage. In order to make Apache Spark fault tolerant, the abstraction introduced in the memory is RDD, which is resilient distributed datasets. These are read-only data structures and immutable basically, and these are partitioned collections of record. So partitioned collection of records. These RDD, which are partitioned collection of records, Spark can process them in parallel. And the most important thing is that the resilience that we are talking about, it comes from a concept called as lineage, which can be understood in a very simple way. Spark does not store the data; it just remembers, let's say, the recipe that how that data was created. Now what happens that a series of transformation must be done on the data, right? So Spark remembers the transformations that were done on each RDD to create it. And if a machine fails, so if a machine fails, what happens that a, a partition of RDD is lost, right? So in that case, what will happen? Spark will just use this lineage to automatically recompute the data. And this is all about the missing partisans only, all without the slow, the disk based data that we need to go there and fetch it back, which is IO operation and it is slow. And there is also another holistic optimization, which is a DAG. So I will talk about it. Let me just show you here. So yes, DAGs are directed acyclic graphs, much like in DSA you must have read about them. So before executing a job, Sparks build out a complete roadmap of all the transformations and actions that will be required during the process to and how we can optimize it. Sparks does all of this before the process starts. And what it do, it chains them and forms a DAG, which is a directed acyclic graph. So there are no cycle. So each step is like optimized by the Apache Spark engine, and eventually what will happen that combination of this in-memory processing, RDD based fault tolerance and DAG based optimization, it will lead to the most efficient path, and the most fastest path that is available or possible to complete the entire process that will be followed. So let's talk about how Apache streaming model works. So instead of handling entire event one by one as it is coming, there is a concept of micro batching where what actually happens that the Spark streaming engine, we will discuss this engine in detail sometime later. Let's say Spark streaming. It listens to a live source. So it will be listening. This is a very bad year that I have drawn. So it is listening for events that are coming up, and it will collect all the data that arrives within, let's say, 1 second. And then likewise 1 second. So these, it what it will create a micro batch of 1 second. All the events that came during this 1 second, it will create a batch of it, and then it will process it again like a batch wise manner. So even though data is being processed as it is coming, but there are concept of micro batching, due to which it is not actual real time, but it's near real time processing. So bringing this, yes, it brings a little bit of latency, but that is totally upon the organization if they are ready to, allow latency, or if there is something else that is required, then they again go for some different kind of options if they cannot have the latency. Let's talk about some of the key features of Spark. We are now talking about page number 3 of the research paper that we are discussing. So here, in terms of features, there were 5 parameters that I have also highlighted in the paper that you can see in the description. The link will be there. So speed, usability, advanced analytics, runs everywhere, in-memory computing, and real-time processing. So mostly, if we summarize this, we can say that Apache Spark as a platform is 100 times faster than the predecessor MapReduce that we were talking about. It can be even 10 times faster than MapReduce, even when it is accessing the data from the disk. So for the same thing that MapReduce was doing, Apache Spark can do is 10 times faster. And if it is handling like in memory, then it can do 100 times faster. And all of these things are being achieved via RDDs and in memory storage, like I said. When we talk about usability, so the creators of Apache Spark gave APIs to use it within the to talk to the actual engine of Spark. We can talk with via Java, Scala, Python, and R, and all of these languages are being used in the industry by data analysts and software engineers. So it is very easy to communicate and implement the code to talk with Apache Spark. On page 3 only of this research paper, there is a section B of use cases of Apache Spark, where they discuss that where it is being currently used. So healthcare, finance, e-commerce, entertainment. I've again highlighted a few of the important things that you can again go through in the PDF that will be attached. And the paper talks about how Apache Spark is being used in healthcare to analyze the patient records and genomic data to process them and predict health complications, and basically reduce the risks of diseases, upcoming diseases, based on the big data. The hospital have medical records of lakhs of patients, so they can analyze it and find crucial patterns that, okay, if these are the symptom, hopefully like this person can face this as well. So that helps from a perspective of finance, because I come from a finance fintech basically background. So in finance, Apache Spark can power real time detection of fraud by analyzing the transaction that are being done. Apart from that, in e-commerce, basically whenever a customer is ordering something and it is adding something to the cart, based on the past orders, the company can again analyze that if, say, someone is adding a bread, then how much we have seen this trend that 1 lakh other customer also added butter or also added milk, so they will recommend you milk in the cart. So these things, data from these things, patterns from these things can be seen by these big companies. Next thing coming up is section C of the research paper, which is talking about the Spark ecosystem. I have created a color diagram, which is exactly similar to what is given in the research paper. So we will come to this again and again, eventually, for the next 4 or 5 slides, because they have talked about it a lot. They have talked about the libraries that are present over there. So we will talk about it and then we will go to the architecture. So we have established till now that Spark is really fast, flexible, and unified. But what does that unified means? A critical mistake that often people think that Spark is just a tool. Spark is actually a platform where multiple tools have been hosted, like, at a single place. Now, think of this as an example of your mobile phone. So, let's say you have a mobile phone. In this mobile phone, there is a Play Store, and you have your own operating system. So, this operating system and the entire hardware, but operating system, let's say, that is similar to Spark. This operating system is giving you a tool, let's say Play Store, where different kinds of apps are there. Camera is there, games are there, different kinds, calculator is there. So you can then use these apps to do your own work. Likewise, Apache Spark has two main segments. One is the Spark core, which is the computing engine, and another are the service API. Now, the bottom box, the Spark core computing engine, is the heart of Spark, and it basically exposes the fundamental APIs for the most popular data languages, like I discussed in the last part. So, R, Scala, Java, SQL, or Python. And when you write a Spark script in Python, what will happen that you are directly interfacing with this core engine. So you will write anything in Python and it will directly interact with this engine. And this engine is responsible for analyzing your code, creating a plan, and then let's say analyze, create plan, and eventually what it do is it handles all the distributed tasks. This is the engine that actually provides that in memory capabilities that Spark is famous for, and it is a low level engine. It powers the entire foundation for everything else. Now look at the top box, that is the service APIs. These are basically high level specialized library. So let's say library which are basically specialized and built on the top of the core. So each one of these component, the Spark SQL, Spark streaming, or whatever GraphX, these are the library just make calls to the underlying core engines. They are making calls to the underlying core engines, and this design is brilliant because it is modular. Now, you can pick and choose only the components that you need. If you need only SQL, you need only streaming. And likewise, if you are a data scientist, you will be working mostly with, let's say, machine learning library and Python and maybe R. So, if you are working with only these three, you can work with only these three. Basically, what I want to say is that this separation of concerns is what makes Apache Spark very easy to use, easy to understand, and it has been, like providing this specialized high level tools for common jobs, while we can rely on this singly optimized and already tested platform to do our regular work day to day. Here is the same thing that we were discussing a few time ago about Spark ecosystem. We talked about the two main layers. We talked about the key component. Now let's discuss all of these key components again in detail one by one, so that we can have a better understanding of each of these component. So as we were discussing, there were total of five: Spark SQL, Spark Streaming, MLib, GraphX, and R on Spark. We will discuss these each one by one. So let's start our discussion with one of the most used thing, which is Spark SQL. So before Spark SQL, what used to happen that if you want to query a big data using SQL, then you will write the this MapReduce jobs code manually, and eventually that job will run. It will take 4 hour, 5 hour, 12 hour, 24 hour, depending upon how much data we are getting trying to process. And eventually, after all the waiting and all, you will get the result. So Apache Spark, when it came, it changed the game because the processing time was again so much, like 100 times faster. So we were getting data so much faster that we can actually analyze it really quickly. Because think from an analyst perspective. So if I have a chain of thoughts, right? So as a person, I want to test something. I have a hypothesis. I route the query that, hey, show me the data for this. And now the data will come after 8 hours. My chain of thoughts will be gone after 8 hours, right? So it's very difficult to do this. And after 8 hours, if I get the data that eventually, okay, now I want to check another thing that, oh, hey, what if I add a filter on top of this? Now again I need to wait for 8 hours. So this is problematic, you see. So this is why what we are doing here is in memory computation, which is making it faster. All right, let's talk about Apache Spark SQL basically. So Spark SQL purpose is to be distributed framework, especially for working with structured or semi-structured data. You can think of tables from a database, CSV files, log files, or massive JSON objects. So its key functionality is to let you run interactive SQL queries on these massive data sets. And because it runs on the in-memory Spark core, so these queries are basically incredibly fast. So we are talking about seconds or minutes, not hours. And this is revolutionary because it is bridging the gap between the data engineers and the data analyst. So analysts who used to, live and breathe is SQL. Now they can just query petabytes of data in like seconds and minutes, and they don't need engineers to write the queries or custom application for them. So the central abstraction in Spark SQL is the data frame. So any person, if they have worked with like pandas library in Python, so a data frame is similar to that only. So data frame is quite simply a table of data with a named column, just like a table in a relational database. But the difference is that this table is distributed across your cluster. So this data frame will be not stored in a single place but across some server 1, let's say server 2, server 3, and likewise. And now Spark will run queries on top of it, and then it will give you the result. So the purpose is to have a distributed framework, because we cannot store the big data at a single place because it's so big. Spark SQL can read data from numerous sources. Let's say, like I said, JSON file. There is one more format called Parquet files. It is a very popular columnar storage format. I will create another video in future, most probably, about Google Dremel, which is their analytics engine. So there we will talk about this columnar storage and the Parquet file again. Hopefully. So then we have it can be like data source can be Hive tables. All right, till now we have discussed Apache Spark SQL. Now let's discuss Apache Spark Streaming and mlib. Both are like one is streaming and one is for machine learning, as the name suggests. So Apache Spark is like again for processing real time events or data. So it can connect to most of the platform, let's say Amazon Kinesis or IoT devices or Kafka, and then it can process all of these data using its micro batching technique that we discussed. Apart from that, it can. Now, what do you do with all of these streaming data? And this is where the machine learning library mlib comes in. So mlib is Spark's built-in machine learning library, and it makes large scale machine easy and scalable because it's built in within Spark. It is delivering a very high quality algorithms. So most of the machine learning algorithms, if you have studied in college, they are already there. You can talk about classification, regression, and evaluation, but not only that, it also bundles you all these tools to basically create the entire pipelines for machine learning. So let me give you an example of where we can use this. So what we can do is we can use Apache Spark and train it on a data of, let's say, 1 million fraudulent transaction. So once our model is trained, we can use this same model and then deploy it in a Apache Spark streaming platform pipeline basically. So whatever real time transactions are coming, they will go through this model, and we can actually classify that whether or not this transaction that is happening right now is a fraudulent transaction. It might be a fraudulent transaction or not. So there are two more things that are yet to be discussed. First is GraphX, and there is R on Spark that we will discuss. GraphX is a library which you might not need to use every day, but big companies often in social media platforms they use it a lot. So this library is being used to like go for the graph based computation. So let's say a person has a social media network, right? So this will be plotted in terms of data structure on a graph. So analysis of this structure, that like what kind of people you connect with normally on LinkedIn. So this can be done via a GraphX library. Let's just talk about Spark Core. We have been talking about it since a long time in the video. Spark Core is the actual component which goes through the distributed task, does the scheduling, the IO functionalities, and also it also handles what to say the RDD abstraction in memory computation. So RDD in memory computation, and all of these things are being handled by Spark Core only. So every query that you sends via the other platform, it is eventually coming to Spark Core engine only, and it's very rare that you can actually directly access the Spark Core. But eventually, behind all the scene, it is the actually unsung hero. All right. I think this video has been a bit long for now, and I still have few more pages to cover in this research paper. So what I will do that I will make a different video, the continuation of this video, as a separate part, and let's call this video part one. And in the next part, we will discuss the architecture, the hardware requirements, and where it is being used in the emergent technologies. And I think that will be a good thing to have because I need a break in this video. So all right, I will see you in the next video, and if you have watched till here, thank you. And it's really interesting to understand these technologies very deeply, going into each thing, and reading about them. So hopefully I will see you in the next video, and let's continue and finish this paper together.